Hi everyone, this tutorial is Introduction to Registers. Now, before I start talking about registers, we need to understand the difference between combinational and sequential circuit in memory block, because there's a difference. Now, sequential circuits um, have memory block and feedback, while combinational circuits no memory block, but there's a feedback. Now, let's clarify that. Now, combinational circuit is a type of circuit in which the output is independent of time and only relies on the input present at that particular instant. While sequential circuit is a type of circuit where output not only relies on the current input but also depend on the previous output. Now, the problem is to design a memory block to store a single bit of data using flip-flop. So then why don't we store multiple memory uh, data using blocks of flip-flops? So rather than one block with one data, then we can use multiple flip-flops with multiple data. So we start by designing one flip-flop because one flip-flop is one bit memory cell to store a single bit of data. Now, so if we have 0 or 1, then we don't have a problem of doing that. But what about multiple data, such as, for example, I'm going to use in the next example 1011, which is 4 bits involved. So that's why it's very important you need to understand flip-flop circuit in my previous tutorial to be able to understand why we are using flip-flops. Now, to increase the storage capacity, we have to use a group of flip-flops. Like I mentioned, with one flip-flop, we are able to store a 1-bit memory cell. So if we want multiple bits, then we have to increase the number of flip-flops. So to increase the storage capacity, we have to use a group of flip-flops. This group of flip-flop is known as register. The n-bit register consists of n number of flip-flops and is capable of storing n-bit word. So flip-flop is 1-bit memory cell. So let's look at this example. As I mentioned earlier, we have no problem if we use 1 or 0. But what about if we have 1, 0, 1, 1? Now, as you can see here, we have a clock. Now, the clock is internally connected to all flip-flops and applies the same time. So rather than having clock in every single flip-flop block, why don't we just have one clock generator and given to all operations so they all apply to it, are all connected at the same time. But the things with this, we are bound to follow this clock. So they all gonna have to follow this clock. So following that clock can be a problem because frequency equals 1 megahertz. Time period equals 1 over frequency in seconds. So time equals 1 microseconds. So time equals 1 microsecond. So after every 1 microsecond, whatever stored in the flip-flop will change. So what's the point of if we can't keep the memory here forever, so what's the point? So here data is changing after every 1 microsecond. So we don't want the falling edge here, the falling edge, to change when we input, for example, 1. So when I input 1, I don't want the data to change when we have the falling edge. So in order to stop losing the data by the changing of combination, we have to use something called independent control. Now the independent control here called load. So load kind of will help us to be able to control this. So we have synchronous and asynchronous. Now synchronous is a clock when a clock is high and load is high. When the clock is high, load is high. The synchronous only load is high to change the value stored inside. So let's have a look what that means. So here, as you can see, if stored data for 100 microsecond, load is made low here, so it does not affect the data. So when I have a falling edge here, as you can see here, for let's say if I want to store data for 100 microseconds, load is made low. So the input will not change inside the flip-flops. I hope you able to understand this. As I said earlier, in order for you to understand how flip-flop works, please watch my previous tutorials on flip-flops.